Can I
Um,
ask you something really fundamental about all of this? What is a what are these forces? It sounds like magic to me. Like, how does a force work? Like, how do they materially bind something together? It seems like it's just a ghost or something.
um, well, let's take two electrons, and the force between them is called the Coulomb force, after invented by the physicist Coulomb. And magnetism is a magnet, positive, negative poles, and that was started by Faraday, physicist Faraday, and
Of course.
Maxwell put it together, okay, to Maxwell's equations. And for the two electrons, the Coulomb force, which is a one divided, is an inverse square force, like gravity, 1/r squared, between two electric charges. And in quantum field theory, that is described by the exchange between the two electrons of a photon. The photon carries the force. And I can prove this experimentally. I mean,
I
theoretically.
understand that, like, when that here we're referring to these forces as this attractive phenomenon. There's some sort of attractive phenomena,
That's
and
right.
alternatively, you could have a repulsive phenomena. And it makes a lot of sense to me that, like, if I take a bat and I hit a ball, there's going to be a repulsive phenomenon because one material is pushing the other material out of the way. So the force is push there, and you're hitting the ball, and the ball's moved out of the way. But when it comes to two electrons, what is the force? What is happening there? Like, are the electrons touching each other? They must be. I mean,
No,
I
no, no,
can't. They're not touching each other.
no, no.
So what is that? Is it magic or something? Like, what is doing that?
No, it's a field. A field carries the force.
And is the
It's
field?
the,
Um, Go ahead.
it's
Oh,
a field that permeates space-time.
but the
The
field,
electromagnetic field.
when you drill down to the question of what is a quantum field is a set of vectors that change over time. It's a mathematical quantity
That describes attraction or
that
repulsion.
describes attraction and repulsion. And so to me, it seems like quantum field theory says that mathematics is the fundamental is what the universe is built out of. And that alarms me because do you know Max Tegmark?
Well, you see, it's all based on mathematics. It's a model, and the whole of physics is based on this big model,
Mm.
and mathematics is used to describe the model.
So
And
the mathematics, you,
what is a mirror? What is a miracle? Is that it works
Well, mathematics is
because when I
wonderfully descriptive, right? It describes how these quantities change over time, but the thing that it can never do for us is explain, in other words, interpret what is happening mechanically. Like, what are the actual physical actors doing? Like, I can describe the motion of this cup and the motion of the liquid in it with mathematics, but ultimately there's atoms that are bumping into each other, and my hands atoms are displacing the cup's atoms, and it's very simple, right? I'm either pushing on it or I'm pulling on it. Those are really the only two forces at play in my everyday life. It's not like I can do anything else. And so, does it trouble you that we don't spend more time as scientists thinking about what the interpretation of those fine-grained mathematics mean in terms of the structure of the atom or the structure of the electron? Nobody seems to really be working on that. It's like sufficient that we can
well,
describe the behavior very well.
you don't when you do gravity. When I do my gravity, I don't try to explain what gravity is.
Right, that's what I'm talking about. Why is that? Why don't people
No
worry
one
about
does.
that? Yeah, I
There
know,
are
nobody
certain
does.
questions you don't ask in physics.
Oh, come on, but I want to ask those questions. Those are my
Well, you
favorite
can ask them.
questions. Yeah.
wait, why is
People
physics?
did ask them
Why do you not ask those questions in physics? That seems perplexing to me.
Like, if you don't ask them in physics, where else would you ask them?
Is that a religious question?
because it doesn't get you anywhere.
Interesting. Why not?
Technologically, perhaps.
Well, yes, because this is something that I've noticed a lot, which is that physics is really so. The mathematics of physics is fantastic for engineering. If you want to build something, the mathematics is really good for
Or
being
make predictions.
or make predictions. What else?
No, that's about it. Yeah, if you want to build things and you want to make predictions, you're going to need mathematics. This is technological engineering side of things, and that's what's super valuable to human race, obviously. So I think you're right that materially explaining what the electrons are physically doing doesn't get you anywhere in terms of technological or predictive power. But
I
it is
wonder,
fascinating.
and not only is it fascinating, but I wonder if it isn't useful science is the discipline of mechanism, right? It's not just a mathematical description. I'm a biologist by training, and something that alarmed me. Yeah, exactly. The ATP pump is a great example. So I'm a biologist by training, and I studied metabolism inside of bacterial cells. And metabolism is a fundamentally electrical process. And something that always alarmed me is that the cells are sensing charge. They're sensing their redox state, which is the balance of reduced species to oxidized species. When you look at the metabolism inside of a mitochondria, you have a proton gradient, and the proton gradient falls through the ATP pump, and it produces ATP by spinning this turbine. But when you get down to it and you ask, what is it about charge that is doing the spinning? How does it spin the thing? Not describe mathematically the curve along which it will spin it, but what are the molecules doing that actually...
What is charge?
What is charge?
Other than a repulsive effect. What causes the repulsive effect?
The answer is exactly what you say. That's not what we do. And it alarms me because the biologists kick it to the physicists, and they're like, the physicists know the answer to that question. And you go to the physicists, and the physicists also are like, that's not what we do. And so, where do I go, Professor Moffat?
Yeah, do we need a new department in the academy to study the material interactions of tiny things?
I've even done solid state physics. I mean, I should say even done, but I didn't mean that in a derogatory way, but I tend to stick to the so-called fundamental physics. But I have published papers on condensed matter physics years ago. Anyway, well, these are difficult questions to answer.
Well, there might not be answers. I'm just curious if you've thought about it in your career, or if you've encountered others who have thought about it, and if there is a place in the academy for such questions to be asked.
Well, Descartes considered, there was the first theory of atoms was by Thomson, Lord Rayleigh, and a Scottish physicist called Tate. And they claimed that atoms were knots. Reminds you a bit of string theory, by the way. And they invented knot theory. And they could claim to explain some issues of atoms. Then Niels Bohr came along, and Rutherford, particularly Rutherford, showed that the atom consists of the proton, hydrogen atom, the simplest atom, proton, electron going around. So it's got nothing to do with knot theory, even though knot theory was a very elegant theory. In fact, there's a whole mathematics of knot theory.
That's right.
Similarly, can be said about strings. All the elementary particles are actually strings, like strings on a harp.
Except they have no width or height.
The problem is it has to be done in 10 dimensions or 11 dimensions. And no one's ever detected any spatial dimension above 3. So string theory, I've worked on string theory some years ago, and I decided I didn't like it. I still don't. You can't test it. But that's another story. Yeah, there are certain questions you ask in physics which get you to going forward to understand how particles move with respect to one another, or how forces work and so on. And there are other questions you don't ask, like, what is gravity? There have been many papers published in earlier centuries, people trying to explain actually what gravity is. Newton didn't do that. He constructed the laws of gravity. He didn't worry about what gravity is.
He might have worried a lot, but he didn't publish on it. Yeah.
Yeah, well, he was into a lot of religious activity, and
As was necessary in that day.
make gold out of lead or whatever, alchemy. He was a strange man.